Hi, I'm JD Arnold, and I'm doing my teaching topic on construction steel, its history, manufacturing, and facts, etc. Learning objectives: learn about the history of steel and and metal structures, what makes steel the best choice for structural purposes, how iron ore is turned into steel, and how steel is produced. I've also thrown in a few interesting facts at the end. So, the history of steel. Prior to the beginning of the 19th century, metals had little structural role in buildings except for in connecting devices. The Greeks and Romans used hidden cramps of bronze to join these blocks of stones. So, cramps, nails, spikes, and many other types of wood connecting devices, or just any metal connecting devices that were created. That's what they were used for. Architects in the Renaissance counted the thrust of masonry vaults with iron chains and rods. So, like in the movies, you see these big doors that are lowered with chains. That's what we're talking about right here. The first all metal structure was a cast iron bridge that was built in the late 18th century in England. It still stands across the Severn River. I put a picture of it in over here. Thought it was really cool to see how even back in the 18th century they were able to do these like designs with the circle here and the arc pattern, and just interesting how they were able to make this, especially out of cast iron where they were technology wise. Cast iron and wrought iron was used in the first half of the 19th century in Europe and North America. It was limited because cast iron was unpredictably brittle and wrought iron was very expensive. This made it hard to build with because you could not predict what cast iron was going to do in its strength all the time. And wrought iron is relatively expensive at this time. Up until the 19th century, steel was a rare and expensive material. It was made in small batches and used for weapons and cutlery, things like forks, spoons, firing pins, and just little designs in the kitchenware and weapon industry. Not until the 1850s did steel become plentiful and inexpensive. This was because of a process called the Bessemer process. The Bessemer process is where you blow air into a vessel of molten iron to burn out the impurities. Now, impurities are all the elements and miscellaneous things inside of iron ore that we do not want to be in steel. So we burn them out and we use other methods to get these impurities that we do not want out of the iron ore. This resulted in a batch of iron to be turned into steel in 20 minutes. Another process used to produce steel is the open hearth method. Now, when we talk about steel has the element of carbon in it. Carbon is a crucial part of what makes steel the optimal metal of choice. Too much carbon makes the metal very hard and brittle, like cast iron, and not enough of it makes it malleable, like wrought iron. Steel is a range of alloys of iron that contains less than 2% of carbon. Cast iron contains 2 to 4%, making it hard and brittle when it forms up from the molten state. Wrought iron metals contains less carbon than most steel alloys. This makes it malleable, so where it bends easily and doesn't have as high of a strength, and it's not as hard and dense as steel or where we need it to be, so it can be structurally supportive. Now, mild steel contains 0.3% of carbon. However, it also contains beneficial elements such as magnesium and silicon. It also contains important impurities. This means mild steel has been optimized to be the best choice for structural purposes. Now, beginning the process, we want to start with iron ore. So, to turn iron ore into steel, you must begin with smelting. Smelting is done in a blast furnace, which is charged with alternating layers of iron ore, limestone, and coke. Coke is coal that its volatile constituents have been distilled out, which leaves only carbon. The coke is burned by forcing large quantities of air into the bottom of the furnace. Burning the coke releases carbon monoxide. carbon carbon monoxide is released because all we have left is carbon. So obviously when you burn it, it leaves carbon monoxide. This reacts with the iron ore. This reaction reduces the iron ore to just iron. The limestone forms various impurities that float on top of the molten iron. This is called a slag. The slag is something you do not want in your iron, so you must remove it while it's in the molten stage. Molten iron is collected at the bottom of the furnace and held in a liquid state for processing into steel. Now, making steel. Roughly 40% of North American steel is made using the basic oxygen process. This is a process where a hollow water cooled lance is lowered into molten iron and recycled steel scraps. A stream of pure oxygen is then forced through at a high pressure, which burns off unwanted impurities and excess carbon. This allows us to reduce all these impurities and excess carbon, and we can kind of control where we want it to go. So you can make it so it burns off more and make the steel a little bit more flexible, or you can leave a little bit extra in there and make it a little bit stiffer of a steel. Lime and other materials are added to react with other impurities, particularly phosphor. All of this forms another slag, which we do not want, and we discard the slag. The slag is mostly contained of impurities and extra components that we throw in there to react with elements and other impurities that are inside the iron ore. Finished steel is then poured into beam blanks or blooms for their desired final shape. They are then rolled into their final form. Now, the production of steel shapes. Steel production takes place in structural mills or breakdown mills. A beam blank is reheated and rolled through rollers that squeeze the metal into more refined shapes and sizes. Once the metal has reached its desired shape, it is then cut into smaller pieces. The cutting is done by a hot saw, and a hot saw is just a specialized saw that is used with unique blades that cut the steel beams, blanks, whatever you want to call them, into their desired shape. Now, this is done with a machine more than it is by hand because you're cutting through steel. The pieces are then loaded into cooling beds. Once they are cooled, roller straighteners correct the crookedness from when they cooled down. They are then cut again, labeled, and shipped to a fabricator. The label contains the shape and the number of the batch it was produced from. Now, here are some interesting facts that I thought were cool about the steel industry and steel itself. So, steel is the most recycled material in the world. What this means is every time we make steel and we have molten iron, we can use steel scraps or recycled steel, put it in there to make the steel make that molten iron into more of the steel that we're looking for. Steel is the most economic and has the highest strength to weight ratio. So with it being the most economic, meaning it is like the cheapest and the most available one that we have in our industry for building purposes. It also has the highest strength to weight ratio, meaning that if we need a building that's a little bit lighter but has a higher strength, we're gonna want to go with steel, because even though steel is significantly heavy, it is also even more significantly stronger, especially compared to concrete. So here you can see steel bridges are 4 to 8 times lighter than bridges made from concrete. That should just tell you that steel is more effective, and we might even be able to get away with using less steel than we have to use for concrete. If we use concrete, we're gonna have to make the whole thing concrete, where steel we can kind of use angles and things like this to make the structure strong enough to do the job. Over 75% of the steels used today did not exist 20 years ago. So you can see that we're constantly coming up with new ways to create these steels that we're making and make steel stronger, more effective, and lighter, and all these other factors of steel. This will allow us to keep producing steel at greater rates while improving the quality of steel. Now, the steel industry also employs over 6 million people. This is just great for the industry, just in the fact that we are providing, like the industry is able to provide jobs worldwide, and it's over 6 million, which is a very large number. Any questions, feel free to reach out. Here are my sources, the textbook, and I got my facts, some of those interesting facts from the worldsteel.org. Thank you.